So the project that we worked on was in collaboration with Evenline, which is a small startup in New York, in the States. And what we did was we designed an interlocking glass masonry unit that could be produced using additive manufacturing. But alongside that, we also had to develop different methods in order to actually manufacture these items. So it uses a combination of additive manufacturing and casting, or solely additive manufacturing, to produce these. So these different manufacturing technologies that we developed, or methods of making these interlocking units, required a couple different steps. One, for being able to print and cast in items. The printer itself uses a molten glass extrusion process in order to print objects, which has been developed a number of years ago. But what we did to advance that technology was, one of them was a combination of printing and casting. So printing a unit, putting on top of a graphite mold, and then ladling molten glass inside of that, inside of a kiln. Another method that we had to develop was how to make these features that exceeded the parameters of the printer. So one of those was the overhang limit. And what we did was print inside of a graphite mold that was seated on top of the build plate that the printer typically uses. So by using a combination of casting and printing, and also build plates with features machined into it, we were able to advance the technology of molten glass printing. One of the aims was well, there were a couple different parameters that we were interested in investigating. One of them was circularity. So how can you start making components, glass components, that interlock with each other so that you don't have to use adhesives necessarily as an interlayer between individual glass units? So what we're envisioning is, can you use additive manufacturing to, one, reduce the amount of waste involved with molds or anything in the casting process that you might otherwise use, but also the element itself is all glass and can be deconstructed and either reused or recycled down the line. Initially, you could maybe have some interior walls that are non-load bearing, but we do envision something where you could have facade systems similar to what you're seeing in 3D printed ceramics right now, and here in Delft as well. So something that could be load bearing in the future as well, not just a false facade. There are a number of limitations. One of them is really the size of the machine right now is you can only extrude onto a build plate of a certain size because it's printed inside of an annealing chamber. So you could make a larger machine that could extend the build plate or the size of it and start printing much larger items. The other thing that you deal with glass is you also have a lot of limitations as far as like overhang, what is the minimum path length so that the glass cools to a point where you can deposit another layer on top of it. These are just some of the geometric limitations, but I also think that these differ greatly from limitations you see in casting. And so you can start finding some places where additive manufacturing might be a better application depending on the form that you're trying to design or manufacture. I think there are certain limitations with molds. I mean, obviously there's some limitations in the manufacturing process as far as the cost of being able to make different molds, especially if you're using reusable molds. But also you have a chilling factor. So the longer your path of where the glass is flowing into the mold, the faster it'll cool, and you have some limitations there. When you're using 3D printing, or the type of 3D printer that we're using, you can have a pretty thin wall, but extrude it along a long height or length. And so that's one application that I think we're particularly well suited for producing. Definitely an amazing material to work with. I had no glass experience prior to starting my graduate program at MIT, so I really think that the interesting part of what I've been studying is the combination of the craft experience of glass workers working with the material for many, many years, but also the emerging technologies that are implementing the material in the built environment in particular shows a lot of promise for the future.